Hello, this is Mr. Radish, and today we're going to be talking about the study of life, which is biology. In the process of studying biology, it is the goal of science that we understand nature. And whenever we understand nature, we come up with several things, such as a hypothesis. But before you can come up with a hypothesis, which is a testable question, you need to make an observation. So whenever we look at this picture, several questions come to mind. Which is male and which is female? How do they interact with each other? All of these things are testable questions which can be formed as an if-then statement, which we will talk about later. After you have several supported hypotheses about a same thing, then it's called a theory. Numerous theories that are supported are called scientific law. One of these things about scientific law that you must understand in scientific theories is that scientific ideas can change. And then one of the ways that we can illustrate this is if we'll look at this picture of this tyrannosaur. This is what tyrannosaurs looked like back when I was a kid. They big thick tails, they walked with the tails dragging on the ground, they were very slow, they were lucky to eat. Oh my goodness, what do we do about those things? Well, let's show you how things have changed. Since Jurassic Park has been around, now tyrannosaurs walk like this. Leaning forward, tail off the ground, very fast, very ferocious. So as you can see, scientific ideas can change, and along with it, how we view the world. The next thing we want to talk about is how this can stand the test of time. Whenever I was, just been a couple of years ago, Pluto, we had 9 planets. So when we look at this picture, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 9 planets. That's not the case anymore. But we do know that the sun is at the center of the universe, or in our solar system, and that we do have 8 planets. They circle around the sun. This will never change because this is something that we know. But one of the things that we have to realize is that science cannot answer all questions. One of these things is that only through observation, whether by mathematics or by experiment, can we answer questions. We can't just make assumptions because assumptions are not stand up to the scientific method. We can't answer questions like, did life evolve over time? But we cannot answer, was life on Earth created through another method? The next thing we want to talk about is how we do scientific methods. First thing you want to do is you want to make an observation. So whenever we look at this cloud, we go outside and we go, oh, there's a cloud outside. I wonder if it's going to rain. So now you've made an observation. The next thing you want to do is form an hypothesis. So after you've asked a question, I wonder if it's going to rain outside, you want to ask yourself an hypothesis. Whenever you form an hypothesis, it must be in a testable question. And whenever you have a testable question, it should be in the form of an if-then statement. So if there is a cloud outside, then it will rain. So you have an if-then statement. In this if-then statement, if the clouds are outside, that's your observation, then is where you answer the question. This is what you're going to test. Then the next thing that you want to do is to test your hypothesis. You want to make a prediction on the testable question. Then you want to draw a conclusion. Okay, so now you have this picture where the clouds are getting worse. And what you want to do is you want to see what's going to happen. So you're going to have to develop a theory, or you're going to have to develop, not a theory, but you have to develop a way that you can test if it's going to rain. This one is going to be by observation. So you're going to have to sit there and wait to see if it rains. If it rains, then you're going to draw a conclusion. Well, the clouds showed up today at such and such time, and now it's raining, so there is your conclusions. And then after you're done, you're going to have to record and communicate your results. And this is where you share it with others. Tell someone what you did. You want to keep accurate records so that if they run the test again, they can follow along with what you did. This makes your test authentic. Then what you want to do in your conclusions, you want to tell us what you did wrong and why it's not supported or whether it was supported. The next thing we want to talk about is experiments. So whenever you're doing your scientific investigation, we're looking at variables and sample size. The larger your sample size, the more authentic it becomes. But we want to talk about variables first. Whenever we look at this chart, this one right across here is your if statement. This is your control variable. This is what doesn't change. This is your independent variable. The y-axis is what's dependent on x. This is your x-axis. This is your dependent variable. The sample size, on the other hand, the larger your sample size, the more authentic it becomes, because if you only test 2 or 3 people, then that's not going to talk about millions of people. So you want to be able to have a large group that is spread out and dispersed, and then you want to be able to repeat the experiment more and more. The more you repeat it, that makes it more likely that your hypothesis will be correct. The next thing we want to talk about is the way that we do our investigations. So whenever we look at our investigations, we have several kinds. Most of the ones that we do in natural studies is mostly observations. We study things that we cannot control, such as the water cycle. You can study this for as much as you want, but there's not too much that you can do to change this. Whenever you can look at this picture, and it's modeling. And what this does is it models the real world. It's something that you can look at, and it's something you can draw on a piece of paper so that other people can see. You can also put it in a PowerPoint where you can move the pictures around, that way everybody's staring at you. These things are used to investigate complex systems in a simpler, smaller fashion. The last one we want to talk about is scientific theories. These are broadly accepted as true, but sometimes these can be wrong in some cases, such as when we was talking about the dinosaurs. And these scientific theories are a series of supported hypotheses. So that's how we look at the introduction to biology. This is a framework where we're going to use to study our class this year. This is something that we're going to model all through the year. Thank you, and we'll talk to you next time.